Hello, today we're going to talk about NAS and the way you can build this yourself in your home. So why would you want to do this when there are so many solutions that are already available on the market? So the first reason is probably around cost. Those two bay NAS appliances from Synology, QNAP or Asus Store, they start at around $400 Australian for a slow CPU and only 2 gig of RAM, and they don't include any drive, so you need to buy them separately, and they tend to be quite expensive, so your cost is going to go up very quickly. In addition, you can't run applications like Plex Media Server on those low-end systems, and you're really limited to the applications that are provided by the vendor. So if you want to do something a bit more complicated, basically you can't. And they are very closed systems, so you can't do anything other than using the web interface to manage and access the system. Secondly, you could go the route of using a PC and install some readily available NAS software like TrueNAS, OpenMedia or RAID, and that's fine. That works really well. It's a really good way of getting into a NAS system, and it's all web-based, and you can do this without running any command line. But again, you're really constrained by the design choices of the vendor, especially the fact that you're going to boot from a single boot drive. And we'll talk about this later. And also, again, the choice of applications available tends to be quite limited. So why is our approach different? So I want to show that it's possible to build a quite nice NAS box with RAID-1 redundancy, booting from the RAID volume, just with Linux 12 and Webmin for the web interface. But keep in mind that this is only for your own use in your own home. It will work fine, but definitely don't try to use this in production in a business environment, because that's really not designed for it, and it wouldn't be supported by anyone. So this will help you understand how your PC is booting, how Linux is handling drive failures, and teach you how to configure things with the command lines. And finally, we will install Docker and show how to tap into the vast library of applications that you can use. So let's understand how Linux is booting and the whole process of booting under Linux, and specifically Linux Debian. All the newer PCs from the last few years are running on what we call the UEFI, which is a Unified Extensible Firmware Interface, which is much more sophisticated than the old BIOS that you might have seen in the previous generations of PCs. There are just so many improvements, but for the purpose of this discussion, we're going to focus on the fact that UEFI is using drives and partitions that are using the GPT schema. GPT is the replacement for the old master boot record system that was used previously, and it is much more powerful and much more flexible. So when you install Linux in a single drive and default setup environment, what happens is that first, when you turn the PC on, the UEFI is loaded, then it will look and find the boot drive, which is normally at the top of the list of the boot order, and it will look within this drive where is the EFI partition. This EFI partition is a small fat partition, about 500 meg, and it contains all the necessary information for the PC to boot under Linux. So in this EFI partition, it will find a small file which is called the grub.cfg file, which will point to, and you can see here that in highlighted the UID of the boot partition, and this will tell Linux where to find the boot partition and where I can load the system from. So then it will load the kernel from this boot partition, and it will look in in the fstab file for the necessary file system. So again, the main boot drive will be this one in highlighted here. It will load as the root file system, and then it will also load the EUFI partition in under the boot EUFI name. So just to summarize, you've got three sections. You get the main EUFI, the small EUFI partition to guide the boot process. Then you've got the boot partition where all the system is loaded, and the swap partition. So that's fine in the single boot drive environment, but what happens is when you buy a NAS appliance or when you install a NAS software, they all use the same principle. They all boot from a single boot drive, which is what we've just described before, and then it will use a RAID array that typically is a RAID-1 mirrored partition using two other drives. So essentially, you get three drives in your NAS system, one boot drive and two drives that are mirrored. So Linux first reads the information in the EUFI partition, then it will start the system, and it will load the RAID array that contains the user data. So it works fine, but if the boot drive fails, so basically your entire system crashes, and the drive must be restored on a new one from a backup. So which means that you need to have a recent backup of your boot drive to be able to restore your whole system. Typically your boot drive wouldn't fail that often, but it does happen. So when it happens, your entire system just crashes. What we're proposing is to build a RAID system that has no dedicated boot drive, so there's no single point of failure, and that will have only two drives in the PC. So the RAID array will be built using the Intel Rapid Storage Technology, or RST, that is built in our PC UEFI system and supported by Linux. So what you end up with is two drives, like SATA 0 and SATA 1. They are embedded in a RAID-1 array, and all the partitions within those two drives are mirrored one to each other, but it is completely invisible to Linux. So Linux will boot directly from the RAID-1 array instead of a specific disk, and if one of those disks fails, so the system will continue, so it will survive the crash of the disk. It can even be rebooted from the second disk as well. So this failed disk will need to be replaced, and then you can rebuild the array using the Intel RST in the UEFI software. Okay, so what do we need to be able to do this? So in this instance, I'm using a second-hand HP ProDesk PC, and it's a very good PC. You can find it on eBay or on Marketplace for very cheap. So I paid this one like $180 Australian, and it's got a Core i5 CPU, 8 gig of RAM. You can increase to 64 gigs, which is really good, because if you want to do things like containers or even virtualization, so it's very powerful. The SSD is 256 gig, but we're not going to use it, and it supports the Intel RAID RST software, which is very important. There are some limitations from the start that we need to overcome. So this PC has got only one 3.5 inches bay available and one SATA power connector. If we want to plug two drives in this, we need some additional hardware that you can buy from Amazon. It's very cheap. So you need a mounting kit for your two drives. This is the one. Then you need two drives, obviously, so they can be HDDs or SSDs. My demonstration will include only HDDs, but you can obviously, if you're going to have a live system in your home, you want to use SSDs because they will be much faster. and then you put those two SSDs on your tray, and you need to connect them to power somehow. To do this, you need a Y splitter, so you can provide power to both drives, and obviously you need some cables that you can buy as well. And if you want to do more things like applications or containerized applications, then you need more RAM, but it's optional. And finally, the NVMe drive will be removed because we want to avoid a double boot situation. Okay? So what do we need to do before we get into the installation? So we need to remove the existing SSD drive, as I said, because otherwise, when you install Linux, it's going to find the EFI partition on the SSD, and we'll actually use that one to create a dual boot situation, which is what we're trying to avoid. So we want to remove this, and then it will create the EFI partition on the RAID array. So we want to install the two HDDs or SSDs, connect the SATA power, and so on. Install the RAM if it's required, and then we want to create the USB installation using the Debian ISO file and Rufus for Windows or Ventoy for Linux. Then that's important. We need to boot onto the UEFI, disable the secure boot. Otherwise, it's making the whole thing much more complicated. So you don't want this. You want to activate the Intel RST software. Make sure that the USB is at the top of the boot order, and then reboot, get into the Intel RST, and build the RAID-1 array. And I will show you how to do this. Finally, you've got your USB installation media, you reboot, and you install Linux. And then I will show you in the next section how to do this. See you soon. Okay, let's boot our PC and do the configuration in UEFI. Okay, the first thing we want to do is to disable secure boot. So it's already disabled here, but essentially you get secure boot disabled and enable the legacy support, which is fine. And secondly, look at the boot options. So you see here we've got the USBs at the top, and we've got our two drives. We haven't created the array here yet, so we're going to do this very soon. And here we need to configure the RAID, and that's probably the most important part. So basically click here, and then it will show a prompt to go into the RAID configuration. And there are a few other things that I've done, but they're not really important here. Okay, that's it. I don't think I've forgotten anything. Save changes. And here I have to be quick. Save changes, yes. It's loading, and then it's going to show the RAID software. Okay, Control I. So we've got our two drives, and we want to create the RAID volume that we're going to call volume 1 is fine. No, I like vol 0. And it's going to be a, oops, come on. Okay, RAID-1 mirrored, capacity, everything, enter. Yes. And that's it really. So you see we get our RAID array is created. Now we finished and we just need to exit. And it's going to boot from my USB drive. Yes, I don't want the graphical one. Yes, English. I'm in Australia. American English. Oh, and this computer is connected to the network using Ethernet. So it will actually get an IP address. Yes. So I want to call this Debian NAS box. I've got a local domain. So we need to create a password for the root. Oops, hang on. Confirm. That's the username. Password. Okay, for the time zone, I'm in New South Wales. Okay, what does it say? Force UEFI. Yes, we want to do this. So we want to do a guided use entire disk. So what it does now is it's going to see the whole array as a single entity. So RAID-1, yes. So all files in one partitions. Well, and okay, let's go through this. So we get a RAID array, 750 gig. You get a small EFI or ESP partition that is going to boot from, and then you get the boot partition that also contains the user data, 748 gig, and a small 1 gig swap partition. Okay, we're happy with this. Change, yes. Let's go. Partition, formatting the partitions. Okay, let's configure the mirror. So I'm in Australia. I like this one because it's close to my place. I don't need the proxy. No, thank you. So we don't want the GUI because it will be all command line based. We do want SSH because this is mostly how we're going to access the system. So this is where Linux is installing the grub into the UEFI partition. So it takes a bit of time because it's a HDD instead of SSD. Setting the users and passwords. Almost there. And that's it. We just need to remove the USB and continue. And it's going to reboot. So it's going to skip this. So let's start. Okay, and the array is clean, which is good. And login. So login as root first. Alright, so the first thing we want to do is to enable our user to SSH into the system, because it will be much easier to do this instead of working on the console. So we need to install first sudo, so apt install sudo. And then we need to add the user gmark to the sudo group. Add user gmark to sudo. Oops. Add user. We also need to know what is our IP address, because I need this to be able to SSH into this computer. So just type IP address, and you see that it is 192.168.1.69. Okay. Now this is all I need to be able to get into this computer with SSH, and I can log out, and I'll see you in the next section. Okay, let's SSH into our new NAS box. So we know that the address is ending by 69. We've seen this just before. So the way we do this is SSH 192.168.1.69. Login name is gmark. I say yes because it's a brand new connection. Type of password, and then we need to do a sudo/i to go into root mode. Okay, the first thing we need to do is fix the IP address, because at the moment it's given by DSCP, and we don't want this. So we need to edit the interfaces file. So I'm just going to paste the command here is this. So we need to open etc network interfaces, and you see that at the moment this is going through DHCP. So we want to fix the IP address, and we're going to use the same IP address. It's not a problem because it's reserved on my router, so there won't be any conflict. It's not hot plug, and I'm just going to paste the content. Okay. So still 69, it doesn't change anything. Save. Quit. Exit. And then we need also to edit the DNS just to make sure that it's the same and the same. So that's fine. Then we need to restart the networking service to apply the changes. System here. Restart networking service. Yes, and let's check the status. Excellent. So now our IP address is fixed, and we can start to have a look at the configuration of the RAID. So first thing first, let's have a look at the content of the grub CFG file. So it is in boot EUFI Debian grub.cfg, and you see here this is the UUID of your main boot partition, and the way it's going to be mapped in the FS tab is exactly the same. So let's have a look first at the different partitions that are set in the system, and you see that this UUID here is the same as this one and this one, which means that because those two drives, SDA and SDB, are mirrored, they've got exactly the same UUIDs, which is exactly what we want. And the same applies to the EFI partition, same UUID and same UUID, and the swap as well has got the same one. So this is just exactly what we want. So in case one of the drives disappears, they get exactly the same UUIDs. Then we want to have a look at the content of the FS tab, because this is how the file systems are defined. So again, you see that the UUID here that you get here is the same that has been defined in the grub.cfg. It's also the same that has been defined as root partition in the fstab file. So it's all good, and the boot EFI partition has got the right UUID as well. So it looks really good. Let's have a look at how the RAID is configured. So the name of your RAID volume is MD126, and we're going to have a look at this with the md adm command. So to be MD126. Alright, it's perfect. So what you have here is MD126. It's got one container, it's RAID-1 system. It's got 698 gigabytes. Sorry, yes. 2 active devices. It's active and clean. and it's mirroring SDA and SDB. Okay, so at this stage we got a fully functional RAID system running on our box, and we can start doing the configuration of the management system, so we can access this a bit more easily. Okay, now we're going to install Webmin. So Webmin is a web interface that allows you to really manage your Linux server much more easily than with the command line. It's all graphical, you can see the performance and everything, which is really cool. And the way it's described for the installation is here, and we're going to do this. But before we do this, we're going to install a few things to make sure that we get everything that is required. So let's just jump back to the command line. Okay. So first we're going to install a few things. First we're going to install the sensors, so we can measure the temperature and the health of the computer. So LM sensors, easy, yes. And secondly, we're going to install the smart monitor tools. So we look at the health of the hard drives. Okay, that's it really. Then we need to install the curl utility, because we need this to actually pull the Webmin installation file from their website. So that's easy. Okay, now we can start doing the installation of Webmin. So this is what's on their website for the installation. We just have to copy this from their website, and it is going to copy a single file, which is the setup repos.sh, and we just need to make this executable like this and execute it. So it will add the repository of Webmin available to the system. Yes. Okay, that's it. And then we just have to execute the command that you can see here. I've copied this already, so all we need to do is run this. Yes. Done. Now, let's switch back to the browser. Okay, let's try to connect to our Webmin interface. 192.168.1.69. It's 10,000. And that's normal, because by default it's using SSL, which we're going to deactivate. So let's continue. And yes, we're up and running. So I'm using my normal username. Sign in. And yes, perfect. So here you've got a number of things, and I will let you discover Webmin on your own, but essentially you've got your host name, you've got the drive temperatures, CPU temperatures with all the different cores, memory, virtual memory, disk space, and so on. So it is very, very handy, very powerful, and it's much easier to manage your computer with this than using the command line. Also the command line, sometimes it's actually more powerful, but here if you want to do something really quick, it's super easy. There's even something that is really handy, is you get access to the terminal directly here. So if you click here, it opens the terminal. You don't have to type any password. It's under your name, and you can even do a sudo /i and your as root in there. So the next stage for us is to let's browse a few other things. There's a file manager, so you can see the structure of your hard disk. You can see a number of things. You can see the processes. You can see the different disk and file systems. You can see the hardware with Linux RAID. Very good. The partitions on the hard disk, A and B. So this is using 3 partitions on both drives. And this one is good because it gives you the smart health of the hard drive. So if I click on this one, so that gives you the health of the system. So in that case, yes, it's good, yes, yes, and you get all these different values. Yes, let's have a look at the second one. So my drives are healthy, which is what I want. Is the system time correct? Yes, yes. Okay. So the next thing we want to do is to actually configure this as a file server, because it's a NAS after all, and if we don't have access to this as a file server, well, it's a bit pointless. Oh, before we do this, there is something I need to change, because we've seen that Webmin is using SSL by default, and we don't have the certificate, so we don't want to use this. Say no, save, and then we're going to lose access to it, because then it's trying to use SSL by default. So I've restarted my browser, which was in private mode, so it doesn't record any cookies, and now I'm able to log in into Webmin without any SSL connection. Okay, let's jump into the file server mode. I'll see you soon. Okay, the first thing we need to install is Samba. Samba is the package that will allow Windows clients to access the file server. So it's a very simple package. Install Samba. Yes. Okay, and the second package we need to install is something called WSDD, which is the way Linux servers are advertising themselves on the network, so Windows clients can actually see them using Windows Explorer. So again, install install WSDD. And that's it. Now we need to edit the Samba configuration file, which is nano etc Samba smb.conf. Okay. Okay, so all we need to do is to add a section here. And this will share the home directory for this particular user, JMark. Save this, we make sure that this does exist. Yes. Oops, JMark, so it's fine. And now we restart the Samba server. System restart SMB service. Let's check status. Okay, we need to create a password for SMB for the user to be able to access the share. So the way you do this is do SMB password and the name of the user, sorry, -a and the name of the user. Okay, and preferably it should be the same as the user password. Okay, now we should be able, let's restart the service just to make sure. And now we should be able to access the NAS box from Explorer. Yes, perfect. Yes, this works perfectly well. And this concludes our session. Thanks for watching. I hope this was useful. Thank you.